So we're here in lesson 4 of trigonometry, and we've taken a look at the basic trig that we went through back in grade 10. So trig identities such as sine, cos, and tan, Pythagorean theorem, angles of elevation, angles of depression. We then went on to sine law and how we can solve for an angle or a side when we do not have a right angle triangle, and we're given 3 pieces of information that work in those cases. We went to cosine law, which used 3 pieces of information that didn't work in sine law. They worked in cosine law to solve for angles and for sides of triangles that are not right angle triangles. In this lesson here, we're going to be taking a look at ambiguous case triangles. And you'll notice there on the top here, we have our title, ambiguous case triangles. Ambiguous just means that there is we're unsure of the exact answer. And we're unsure of it because there may be more than one answer. We might not have just exactly one answer that we're choosing. We might have more than one answer. We're going to be taking a look at why that is the case, and we're going to be taking a look at how do we solve for these types of triangles and when will we have these types of triangles. So we're going to first start off with an issue with the sine law. We're going to be taking a look at why we have ambiguous cases and what the issue is with our sine law. So let's start off with a triangle here. So I've kind of drawn out 2 sides of this triangle, and we're gonna say that angle A is 30 degrees, and so I'm just going to put that in here. This is going to be angle A. Get that in there. And so angle A is 30 degrees. Right there, that's 30 degrees. We're going to say that side B, which is going to be this side right here, I'm going to put B right there, and then I'm going to put our measurement, 12 centimeters. Okay. So we're given those 2 pieces of information. Okay, we're told that our angle A is 30 degrees. We're told that our side B right here is 12 centimeters. Okay, and then we're going to assume, so we're going to know then that this side here must be C. There's got to be a C up here. I'm going to put C up here to start. Okay, it's going to be up there. We don't know what the angle is yet. And then angle B is going to be somewhere down here. We're not sure where yet. I mean, this line stops here, but it could be anywhere. We haven't really drawn this line in yet. So we're unsure where this line is, and so we're just going to put angle B right there for now. This right here is side C, so this is little c right there. And side A is going to be over here somewhere. We don't exactly know where it is yet, and I'll explain it in a little bit as to where it is. All right, so what is the shortest length that side A can be? Well, let's draw in a little line that's going to represent side A. And so I'm just going to put side A in right here like this. Okay, so that would complete it. There would be side A. The thing is, side A could have a number of different measurements. And so we could also have side A to be here. We could do side A here. And so there's all sorts of different measurements. What we want to do is we want to try to figure out what is the smallest one that it could possibly be. And that's going to be this measurement right here. Okay, this measurement from C to, well, now B is going to be here. I'm going to put B right there now. And side A is there. This is the shortest possible measurement that side A could be in this case. Okay, so we could have all sorts. We could have, if you just look at this line here, I need to move my B a little down there. Okay, just look at this line. This would be a much longer line. This would be a much longer line. The shortest that we're going to get is this right here, which, if you you might notice and hopefully notice, this is a right angle triangle. Okay, so right angle triangle. That's going to be our shortest possible side. To figure out how short this is going to be here, we can use our trig ratios. Okay, if we're trying to find this side right here, we have this angle. This is going to be the opposite side. We're given the hypotenuse. We're going to use sine. So let's put that in there. Sine of theta is equal to opposite over hypotenuse. And when we plug that in, it's sine of 30 degrees is equal to the opposite, which you don't know, over the hypotenuse, which is 12 centimeters. Okay. Now, I'm not going to go through and say that this is easy in any way, but this is one that you should know. We do our sine ratio, 12 times sine of 30, and we'll look at that. It's a really nice number. Okay, so when we do that, when we multiply that out, we're going to get that A is equal to 6 centimeters. Okay, that is our shortest possible solution. Okay, it's our shortest possible solution to this triangle. We can have a much longer side, okay, which would make it a different triangle. But in this case here, we have our shortest possible side, and that side is 6 centimeters long. Okay, so this is one thing to just kind of watch out for. This is something to be really careful for. Okay, that's the shortest the side can be, and we're gonna take a look at why that is very important as well. What happens if it is shorter? Okay, so I'm going to use the same measurements, but I'm going to do this on a triangle, except that instead of making A to be the short one here, I'm just going to say that A is 4 centimeters long. Let's take a look at what that represents. Okay, so let's start off with our labeling here. So this was going to be C, this is going to be B, or B is going to be somewhere here at least. We're going to have A to be there, we're going to have little b to be here, and we're going to have little c being here. We have a couple of measurements that we know. I'm still working on how to copy and paste on this program, so otherwise I'll just copy and paste all the stuff from on top and put it on below. We know that that's 30 degrees, and we know that this is 12 centimeters. There we go. Okay. Now, what's asking here, what happens if A is 4 centimeters long? Well, let's look at this line right here. This line right here is 6 centimeters long up on top. If we put one in that is only 4 centimeters long, okay, and we would stick it straight down, it would reach roughly there, okay? That is a measurement of A that is 4 centimeters long. You may notice in this case here that this actually does not create a triangle, okay? At least from what we have seen, it does not create a triangle. It doesn't matter where we put this 4 centimeters. It could go, let's just go here. We could move it up there. There's 4 centimeters long. We can move it down here. There's 4 centimeters. In no case does it actually hit our bottom line here, okay? It doesn't actually create a triangle if it's that short, at least according to what we have seen here, okay? According to what we have seen here. Now, in this case here, we had B as being 90 degrees. Let's use these numbers and let's just see what do we get to try to find what is angle B supposed to be, okay? We don't really have an angle B here, but let's take a look and see what angle B is going to be. Now, in this case, we don't know if this is a right angle triangle or not, okay? So, well, it can't be because we don't have a connecting point here, but we're going to use sine law to show what exactly will become of this one here. So remember, and let's go through again, a little bit of remembering, sine of A over little a is equal to sine of B over little b, which is equal to sine C over little c. And the piece, we know A and B, the A's and B's, or we're trying to find angle B in this case here. So we're going to be trying to find, we have angle A, we have side A. So when we put this in here, we're going to have sine of 30 degrees over little a, which we said was 4 centimeters. So that's 4 centimeters, is equal to sine of B, which we're trying to find, over little b, which is 12 centimeters. Okay. So this is what we know. We're trying to find angle B here. What we're going to do is we're going to cross multiply and divide. We're going to start here. We're going to multiply across. Again, this should become kind of commonplace. We should kind of get an understanding of what we're doing here. This should become fairly regular. We're trying to find angle B. So to solve for angle B, we know that sine B is equal to 12 centimeters times sine of 30 degrees, and then we're going to divide by 4 centimeters. I hit 3 again for some reason. And so when we do that, we're going to find angle B. There you go. Remember this little symbol here represents angle. So this is angle B. When I plug that in here, I'm going to get 12 times sine 30, close brackets, divided by 4. I get an answer of 1.5. Remember, this is sine B, not angle B yet. So we actually have to do inverse of sine of our answer. And our answer is error. Okay, the answer is error. This doesn't actually work. And what it's telling us is that there is, in fact, no angle. We can't actually solve for that angle because this triangle does not work. The measurements that have been given are not possible, okay, in a triangle. Okay, in a three-sided shape, they are not possible. Therefore, this does not work. Okay, and we cannot use it as an example. Okay, just does not work. We can't actually calculate it. So what happens on the calculator when it tries to solve for angle B? Error, as there is no triangle which works with this information. Okay, so we can't actually have side A or angle A as 30, side A as 4, and then we have side B as 12. Doesn't work. Okay, it's a triangle that just does not work. This is an impossible case. There's no triangle that has this angle. Okay. So side A has to be equal or greater to 6 centimeters, okay, as we did here before. To find this, we take side B, okay, multiplied by sine of angle A, and that's going to give us our shortest possible distance. Okay, if the side A is less than that shortest possible distance, it does in fact not work. And so what we can do here, based on what we have, okay, we have B times sine A. That's so whatever our angle is, whatever our side is, if we multiply B times sine of A, our side A has to be bigger or equal to that number for this triangle to actually work. Okay, so I'm going to pause this video right here and move on to our next video afterwards.